Okay, guys, so we're going to talk about measures of central tendency, which you've probably heard of before, and we'll get to the first one now. Average, which you guys have, I'm sure, all heard of before. It's a measure of central tendency numerically describes the average of a set of numbers. We hear the word average in the news all the time. The average mile per gallon on a car is 29 miles per gallon. The average commute to work was 25.4 minutes in this year, and the average household in 2013 was 51,000. Or household income in 2013 was $51,939. Okay. Notation. So sum all the entries and then divide by the total number of entries and the population mean mu. Okay, so this is kind of important. Actually, it's very important because we're going to use this all the time. When we use Greek letters, that usually represents a population. Whereas if we use X bar, the bar should be exactly over the X, but if we use X bar, that's usually indicating a sample mean. Standard deviation, for instance, that'll be an S if it's a sample. And then for population, it will be a sigma. And so if you see a Greek letter, it probably represents something to do with the population. Obviously not always, but in all math, but in most cases for this class, if you see a Greek letter, it will mean it has to do with the population. So computing the population and sample means, so if I give you this whole list, then what we could do is we could put them in the calculator, which I'll show you how to do that right now. If we pull up the calculator, we can go stat, edit, just push enter. I need to clear these. And the reason I need to clear them is because I don't want them to have anything on them. Now we're going to enter all that data. So we've got 8277, 90, 71, 62, 68, 74, 84, 94, and 88. Okay, so we've got all of these. And if we want to compute the mean, we can get that actually really quick. This is just obviously the first step. We can push second. Actually, yeah, second mode to quit that. And then we push stat. And then we go to calc, which is the right button. And I believe it's a 1-bar stat. For list 1, L1, that's the one I listed it on. If yours calculator is not L1, maybe that list that you're using isn't L1, then you may need to reset your calculator to use it. Frequency list, there is no frequency list because we've listed all of the numbers and we don't need a frequency for them. And we're just going to calculate. Now your calculator will always tell you X bar and not mu, but just know that if you're talking about population, it should be mu. We've got a couple of things in here though. We've got X bar, so we've got 79, and that should be the mean for this thing. And so you can see here it matches exactly. The calculator will always give X bar as the mean. That's what I just said. So just know that if it's a population you're talking about, you're actually talking about mu. Now, if you want to do a random simple sample, then remember we have 10 numbers. It shows 3, 8, 10, and 4. And so to do that on the calculator, we did that in another video earlier in this section. We're going to use the random int no repeat though, because we don't want it to choose the same number twice. For instance, we don't want 3 and 3 because we want it to choose 4 unique ones in this case. So obviously you can read through that slide if you need to. For the next one, so they've got 3, 8, 10, and 4. So all you'd have to do if you wanted to use the calculator, you'd add these up and you divide by 4, which would give you 83.3 as the mean. And so what you can see is the mean for the sample is 83.3, But remember, our other mean was 79, so it got a little bit higher, and that just means that the numbers here, when you add them together, they're a little bit higher than that mean with just those 4, and as you start adding more and more, it'll probably get closer and closer to the 79, or it should. Some tips. It may be helpful to think of the mean as the center of gravity for the data set. That's from the textbook. So the next thing we can do is we can find the median of data, and to do this, usually you put them in ascending order. And so what I'm going to show you is, let's say that I have 1, 1, 2, 3, and 4. We have 5 datas, and we want to put them in the most center. Well, hold on, let me scramble this up a little. Let's say it's 1, 2, 1, 4, and 3. In order to take the median of something, you must first put them in order. So we have 1, 1, 2, 3, and 4. And then what we do is we kind of look for the centermost. So these two on the ends match, so they're the first ones out. These two here match, and they're out, which leaves us with only this number in the center. This is our median. Now, what if there are more numbers? Let's say we add a 6 to this. Well, then our number or list becomes 1, 1, 2, 3, 4, 6. Okay, so now when we do it, our red ones get canceled again. Our green ones get canceled again. But the only difference is this time there's 2 numbers in the middle. To take care of the 2 numbers in the middle, all you do is you take the average of them. Oops, I don't like that. So we're going to do 2 plus 3 divided by 2, which is 5 divided by 2, which is 2.5. And that will be your median for this. Now, I hope it's not too bad, but if you look in your calculator, it actually gives you the median. So if you wanted it for that data we entered earlier with 10 numbers, there would be 79.5, so that means there must have been 10. So it must have averaged them, because remember 79.5 was not on the list. So just make a note to yourself that it's not that hard to figure that out and do the median. One thing I want you to pay attention to, there are little formulas. If it's an odd number of observations, which means it's 1, 3, 5, 7, 9, then all you have to do is take the last number, add 1 to it, divide by 2, and then count how many numbers there are once they're in order, and that should be your median. And then if there's an odd number, or I'm sorry, an even number, then you just do n divided by 2. You do n divided by 2 and go to the next one, and you take the 2 numbers, and then you add them together and take the mean of them. So for this one, we're just going to look at it real quick because everything's written here. So you can see that the data determined in table 2 represent the length in seconds. They're not in any particular order, but first step is to arrange them in order. There are n equals 9 observations, so n equals 9 is odd, and so if you add 1 to that, that's 10. 10 divided by 2 is 5. So that means in the 5th position, you'll find your median, and so if you count here, you have 1, 2, 3, 4, 5, and 217 is your median. Now if n is even, let's pretend that they added another number. Well, this is the same example from earlier, but if we do the median, then all you have to do is you do n divided by 2, which is 5. And then you take the next number after that, and you average those. So we count to 5, we get 1, 2, 3, 4, 5. That's 77. Then we have 82, so we add those together, divide by 2, and we get 79.5, and that takes care of that. Obviously, I mentioned this earlier. If you use your calculator, you can see median on there, which is kind of quick and important. Just some definitions now. We have resistant. A numerical summary of a data is said to be resistant if extreme value is very large or very small relative to the data do not affect its value substantially. What does this mean? Let's throw a big number into our data and find out. So if we take the same data, and let's see if the mean is resistant, then all we're going to do is let's go to our calculator. And let's say that I go, okay, we want to go back. We want to go to the list. Let's add a really, really big number now. Let's add 9998, a bunch of 9s. Let's add that number to the list. Okay, it doesn't even put it in there. It says 1e to the 8. Okay, good enough for me. Stat, I'm going to do calc again, and I want to see what happened to the mean. Well, if you look at the mean is now 9090980.818, which is a lot bigger than what it was before, which was only 79.5, no, 79 maybe? Whatever it was before. It's a lot bigger now. And so we would say that the mean is not resistant, because if you add extremely big or extremely small values to it, it will change the mean drastically. If we add that to the median, however, it says add 1,000, but I added obviously a way bigger number. Let's check the median. The median here is 82, which is only a couple points. It's like, what? It was 79.5. So 0.5, 2.5 away from it. That's not too bad. That means that the median is resistant to these crazy numbers that are called outliers. Some final things to think about. Determining the shape of a distribution. Mean versus median. It's skewed left if the mean is substantially smaller than the median. It's symmetric if the mean is roughly equal to the median, so you can see the pictures. And then if it's skewed right if the mean is way larger than the median. So you can just kind of see from these pictures what that is talking about. The next one, to describe the shape, what we would have done in class is we would have put these in the calculator, and we would have found the mean and median of these things, and then we could have determined the shape based on that information. Let's go ahead and do it. So make sure you're practicing, guys. Just put stat, edit. I need both of these. Where is it? Come up. So I'm just going to go ahead and stop this video here, and I'll pick up on the next video.